Alright, quick video overview of the test rig for the Jetcat engine, and then we'll run through a quick startup run and shutdown sequence. Right here, this little motor is the simulation for the fuel pump as well as the closed loop control for speed. We drive the DC motor inside of here with the MOSFETs designed for the fuel pump. And then on the back side here, there's a little rotary encoder that has 12 pulses per revolution. This allows us to simulate up to a lot higher RPM. The starter is connected here. There is the existing Hall effect sensor, the Hall effect sensor is routed into this small chase right inside of this as well, and the magnet is underneath that cap there. This allows us to measure RPM on the actual engine very well with our Hall effect sensor, but we will not be using this Hall effect sensor because we're using the pulsed output from this for closed loop control just for simulation. In the actual jet engine, we will be using that Hall effect sensor for RPM measurement. Moving back, this is the igniter or glow plug for the engine. This is the stock glow plug that's not in the stock location. The stock location is actually down inside of here, inside of the fuel can. We moved it back here so that we could connect the EGT thermocouple to the system. So the thermocouple right now is just wrapped around underneath this tin foil here. This tin foil is just kind of a little bit of a heat containment or heat load for this. So when we start the ignition circuit, it starts heating the glow plug up, and then temperature measurement is from the stock EGT of the glow plug inside of here, and that all reports back to the ECM. So on the ECM here, the ECU. On the ECU here we have RPM in the top left, the command value, which is the specific command input from the graphical user interface, the EGT temperature in the bottom left in degrees Celsius. The 0 that's next to BAT right there is the engine run status. So 0 is off, 1 is startup, 2 is run, and 3 is shutdown. The mode control for the controller locks it into the state that it's in. So once it enters shutdown, you can't command a startup until shutdown is complete. You can't change RPM or anything like that. Shutdown sequence is locked in. Same thing with run. On engine run, the only thing that changes is the RPM command input there, and then the closed loop control will match it on the RPM here. This is our battery voltage right here, as measured on the ECM with this small little circuit right down here. It's been calibrated to match the input voltage, and it's pretty close right now to the supply voltage, which right there is 8.4 volts, and it's fluctuating between 8.4 and 8.5. So on startup, the command comes in for a start. This will change to a 1. At that point, the ignition system starts and starts heating up the glow plug. At 120 degrees Celsius, we say, okay, it's heated up. So that's what that's simulating, is that the engine has ignited fuel and the exhaust gas temperature is up to 120 degrees Celsius, which is from the stock startup. At that point, we will start the starter for our startup sequence, which is a little different from the stock startup sequence, because normally you're just going to have your igniter go for a small delay till it heats up and it's pretty hot. Then you're going to start the starter and dump a little bit of fuel in there, get it lit up. For our sequence, just using the same rough values, we're going to measure the exhaust gas temperature, which is actually the thermocouple measuring the igniter temperature. Then we're going to start the starter at a certain point. This just kind of simulates the same function, but it'll be programmed differently for actually running the engine. So following the starter startup, the ignition system continues to heat up. This is simulating the heat up of adding additional fuel, because at that point we open the second solenoid valve and start dumping more fuel in at a certain point at EGT, and then also on the real engine, EGT and RPM. Once RPM gets above 10,000 RPM, the starter will disengage and the engine will go into run mode, where in run mode it commands an initial value of 33,000 RPM, which is the idle RPM. At idle, the engine will sit and match the commanded value. So the command value of 33,000 is default put in at the beginning of the engine run sequence, then the user can change the fuel pump rate, and then the closed loop control on the fuel pump will match that value on the RPM output and continue adjusting as needed to maintain that RPM. At that point, we'll see a 2 right here for run, and we'll watch the EGT value will continue to increase. The EGT value continues to increase right now because of the glow plug, but ideally on the engine, what we will see is the EGT, or yeah, exhaust gas temperature will correlate to RPM based on the amount of fuel that we're dumping in, so it should settle out on the real application. But in this case right now, we're just leaving the ignition system energized so that it continues to heat up. The reason for that is to enter the shutdown sequence. At shutdown, the starter motor, once the circuit senses 0 RPM, so the turbine has coasted to a stop, and then also senses the shutdown sequence initiation, it will begin starting the starter motor to push a small amount of air through, clear everything out, and then shuts back down, and then measures EGT temperature again, and then starts up again. It'll continue pulsing like that to cool the engine and keep pushing cool air through as the engine cools down. And then once temperatures get below 120 degrees on the EGT value, 120 degrees Celsius, then the whole engine shuts down. You'll see this 3 right here turn back into a 0, which means the engine's in the off state and the whole engine has shut down. All right, so going to a start sequence. All right, that ringing that you can hear there is the ringing of the MOSFETs on the start sequence, or for the ignition right there. We can see the igniter output pulses right there. Voltage does get up to about 14.4 volts on the spike, which was a little bit unexpected. Normally you wouldn't anticipate the voltage to ring that much for a purely resistive load, but in this case there is some ringing that happens when the igniter turns down. So right there we just got above 120 degrees on EGT value, so actually we're all the way up to 140 there. So the starter has started, and then at 150 goes into engine run mode. So now the fuel pump is running and the starter has shut down. We can still see there that the ignition system is still running based off of what we have input. And so coming up here, we can change the command value. So as we change command up to 50, the motor slowly increases up to 50 and will modulate its speed until it is at 50. There is some variance in the data that we'll have to tune out, but tuning it for this motor doesn't seem to be particularly useful because it's so different from the actual fuel pump and what the system we expect to see. So we can go back down to a much lower commanded RPM, which this is actually below what we would expect to command. We'd actually have 33 for the minimum, and then so there's 40, speeds up to 40. Alright, and so when we're ready to do a shutdown, we send the shutdown command, and the EGT sensor right there says, okay, it's still above 120. There's a delay, so it allows it to coast down, and then the starter motor will pulse like this until we see the EGT value actually drop below 120. So there's the starter motor running about 1.16 amps, and it'll just continue to pulse like that until we see everything cool off. Unfortunately, when it runs this way, it doesn't do a lot for actually cooling the thermocouple down because it's not pushing air through closed volume. It's just pushing air out of the back of the compressor here. And meanwhile, this is actually still relatively hot and doesn't have a lot of air movement around it. But it cools down relatively quickly because of how high the temperatures get. So we'll just keep watching this for just a few more seconds until it gets down below 120, and then see that the mode, which right now is 3, changes to 0, and it happens at 120 degrees Celsius on the EGT temperature. Sorry, my video is a little shaky. And right at 120, reset, everything is back in shutdown and off mode, and now we can restart again if we want, or shut everything down and quit the engine run.